minus this 0. So if I do x minus this whole thing, do you agree that's going to change to minus 1 minus 2i? Maybe? And then if I do the other 0, this is going to be x minus, again, subtract the whole 0. So that's going to change that to minus 1, but that's going to change that to plus 2i. And then I can just work this out, right? I can just FOIL it all out. Not really FOIL, distribute property it all out. Which means I'm going to multiply everything in this parenthesis times everything in this parenthesis. And it is a little bit uglier than the one that we did in our notes, but the imaginary part still should work out. So if I take x times x, I get x squared. X times negative 1, I get negative x. X times 2i, it's up to you how you write this, but I'm going to write it as 2ix. And I have to do that for both the negative 1 and the negative 2, which means you're actually going to get 9 terms at the bottom when you're done this. Sorry, did you do this problem yet?
No.
Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And negative 1 times 2i is negative 2i. And then I just have to do it again with the negative 2i. It's going to overlap my lovely little lines I drew. So it's negative 2i times x is negative 2ix. Negative 2i times negative 1 is positive 2i. And negative 2i times positive 2i is going to be negative 4i squared. But I'm going to go ahead and just change that to plus 4 because a negative I squared is negative 1. But the key part to that is remembering that you're subtracting everything. But really, it really is just multiplying it out. And you should see that we have lots of our imaginary parts cancel. Positive 2ix and negative 2ix, those are going to cancel out. Negative 2i and positive 2i, those are going to cancel out. And then I just have all real numbers here. X squared, negative x and negative x is negative 2x. And 1 plus 4 is 5. This would be an example, just like 21, that the answers are both imaginary. There's 2 zeros to this, and it's actually 2 imaginary zeros. And if you did the quadratic formula, you would get back 1 plus or minus 2i. So that means when you get your zeros, you have to write them as linear factor, right? So we kind of like rushed through that at the end of the lesson yesterday. But, like, what was the example? Where did they ask you to do that? Like 27 and 30. So if you look at the back of the book on 27, you should be able to see. I'm just going to skip to the answer on 27. On 27, you should have got a 0 of x equals 1. Right, you got that one to work, and then you can do the quadratic formula or complete the square. And again, it just depends on how you write it, whether you write it as one big fraction or not. But the other 0 was x equals negative 1 plus or minus radical 19 over 2 or something like that. Negative 1/2 plus or minus I radical 19 over 2. Linear factorization means you're going to write them as factors. So if 1 is the 0, could we write that as the factor of x minus 1? That's the nice part, but we're going to do that with this big ugly thing also. And if you look in the back of the book, you'll see that it's very gigantic. But I'm going to take these zeros, and there's actually 2 of them. There's a positive and a negative. And I'm going to do it just like we kind of did with those two, 1 plus 2i and 1 minus 2i. I'm going to take x minus this whole thing, negative 1 plus I radical 19 over 2. That's a 0. And I can also write a factor of x minus negative 1 minus I radical 19 all over 2. And I put them in parentheses there, just like on the last problem, number 6, that we just did. You got to remember that you would be subtracting that whole thing. So I'm pretty sure if you look your answer up in the back of the book on number 27, they're going to distribute that. They're going to give that negative to everything on the top. So they're going to write that as x plus 1, And if you distribute the negative there, you're going to get minus I radical 19 over 2. All I did was distribute the negative. And the same thing on this one. Minus a negative 1 would make that plus 1. And minus a negative would make that plus I radical 19 over 2. And so linear factorization means take the zeros that you get and write them as linear factors. And not that we would want to multiply this out, but if we did multiply that out, we would get back that original problem, is what it's saying. No, you did not have to multiply it out. Right. And that's a good way to check your answer. But right, when it says write the linear factorization, they want it factored, like in factored form is the answer that they want. So I apologize. That's a whole lot of work. Yes.
Can you just tell me the answer for 9 is 18?
What did you get?
I got x to the third minus 5x squared plus 6x minus x squared I minus 5.
I feel like you're missing a tertiary. You should have 4 zeros, right, on number 9?
Yeah.
Like you should have x minus 2 times x minus 3 times x minus I times x plus I.
Oh, I forgot that x. I was wondering why all the i's were negative.
Right, yes, not an I in your answer. So that's like the one that we did in our notes where you have to include the conjugate there. We're not going to have a homework quiz over this day because obviously half the class is missing. But we do have another day of notes for this section. And so we'll probably have like a 2-part homework quiz. I do have the assignment sheet I want to go ahead and give you even though half the people are gone. But if their books are on the desk, we're going to go ahead and give them that. I'll go through this before I forget. Okay, so I'm going to work on passing back your tests and your retests and your test corrections. I have all of those. Yes, so basically like have you already told your teacher yet? So go, you already told her you're going, then you should check in, but then just come straight here and I'll get you started. Okay.